Hello everyone, welcome to all. Myself Dr. S. Indrani, Department of Electronics and Instrumentation Engineering, SRM Institute of Science and Technology. Today topic is Introduction to the course on Fundamental of MEMS. Introduction to the MEMS. The full form of MEMS is Micro Electro Mechanical Systems. Is a technology that merges tiny mechanical and electrical components onto a single silicon chip, integrating sensors, actuators, and electronics. MEMS technology enables the development of miniature systems with the ability to sense, control, and activate mechanical process on a micro scale. What is MEMS? MEMS is a micro electromechanical system, any engineering system that performs mechanical, electronic and electrical function which components in micrometer is a MEMS. That MEMS, micro means small size, micro fabricated sections, electro means electrical signals in and out, mechanicals, mechanical functionality in and out, systems, structures, device, systems, controls. The scales and diagram shows various dimensions in MEMS. The MEMS microstructure dimension is 1 micrometer to 1 millimeter. What are MEMS and microsystems? Micro electromechanical systems are devices that have static and movable components with some dimension on scale of microns. MEMS combine microelectronics and micromechanics and sometimes microoptics. They are referred by different names in different countries. In USA, we call it MEMS, microsystem technology in Europe, micro machines in Japan, smart material and smart structures in India. That MEMS deals with miniaturization and batch processing of sensors, actuators and microstructures. Next, integration of mechanical components with electronics. This is a revolution similar to VLSI in microelectronics. MEMS has batch processing and miniaturization. There are two. Batch processing is cost reduction, reliability and reproducibility. Miniaturization means low power operation. That application is biomedical and aerospace applications. Miniaturization approaches, there are two types: conventional micromachining, silicon micromachining. Conventional micromachining technique, each component must be made piece by piece, low price for larger production volumes are the result of mechanization. Ultrasonic machining, sandblasting, laser ablation and spark erosion have aided in miniaturization. Next, silicon micromachining means suitable for batch processing, is similar to fabrication of the integrated circuits. Production cost of whole production is independent from number of components fabricated. Miniaturization with the finest steels in the ranges 0.1 to 10 micrometer possible based on photolithography. Classification of MEMS, passive MEMS structures or microtips, sensor which respond to the world, the pressure, example pressure, actuator which uses the information to influence something in the world, that is actuator, example is pump, valve, etc. Microsystems that integrates both sensor and actuator to provide some useful functions. The MEMS categories and applications, the MEMS categories application areas, application that the transportation side, the communication side, and areas also analytical medical side. The MEMS structures is infrared imager, optical, RF signal field emission arrays, the analytical medicals, the microfilters, microchannel mixers, MEMS sensor, in the transportation field, pressure, acceleration, angular rate. In communication side, acoustic sensor are used. MEMS actuators in the transportation side, aerodynamic flow control. In the communication side, displays, optical switches, RF switches. The analytical and medical side is a micro pump and valve. A MEMS, the combination of the sensor and actuator, that is called the transducer. Sensor means converts the measured quantity into electrical quantity. Actuator means convert the different type of energy into mechanical energy. That different type of sensor is there: pressure sensor, accelerometer, hygrometer, temperature sensor, gas sensor, flow sensor. In the actuator is micropump, RF switches and resonator, micromirror, ES and comb drive. Structures or AFMT, field emission arrays, microfluidic channel. That why the MEMS is small. For example, MEMS sensor is used in that brain. The normal traditional pressure sensor is a pressure gauge. The size is also big. It is not useful to detect the fluid of the brain. But somebody's any accident in the brain, the doctors using that as a MEMS sensor only. It is not possible the traditional sensor. Need for miniaturization of the sensor. The different type of MEMS sensor used for the pressure sensor, intracranial pressure sensor and blood pressure monitoring sensor. In the marine side having some sensor used, the air pressure sensor, the mapping pressure on LCA wing. The need for the miniaturization sensor is piezo-resistive pressure sensor. That force sensor is connected in the form of bridge. Initially, according to the piezo-resistive effect, initially the bridge is balancing condition. We also applied some pressure. At the time, the having some potential is developed across the bridges. This is the silicon cantilever beam for reduction of the DNA. An array of cantilever treated with the different strands of DNA. When the solution containing different fragment of DNA is introduced, complementary strands of DNA will sexually the blind specific cantilever, creating the structure which defects the cantilever, can detect the damaged DNA sequence since the single base mismatch will cause the slightly different stress indicating the pressure in the damaged fragment. This image for that microstructure or microgear, microderpine, micropump. This is also micropump. Need for the miniaturization sensor. Miniaturization is important for applications. One is a biomedical. In the biomedical field, pressure sensor is used. Micropump controlled in micro dose of drug delivery. Okay, miniaturization is an important for application for biomedical pressure sensor. In the aerospace and automobile is also used in pressure sensor and accelerometer sensor used. Space programs, the pressure sensor, accelerometer, hygrometer, micropumps are used. Microfluidic channel and mixtures, chemical analysis and synthesis and lab on chips concept are used. This is a micro simple example for the micro. The population of India is 1 billion or 100 crores. Each Indian, you or me, is nano in comparison with the total population of India. This is a 1 rupee in a 100 crore rupee for the example for the nano. Why is nano is small is a good. Nano objects are faster, lighter, can get into small pieces, cheaper, more energy efficient, and different properties at very small scale. Surface area increase in size and decreases. How to make nanostructure? There are technologies top-down approach and bottom-up approach. This example for the top-down approach, building something by starting with a larger component and graving away the material like a sculpture. In nanotechnology, patterning using photolithography and etching the any material as in building integrated circuits. The rock is converted into such. This is the best example for the bottom-up approach. Brick, that a number of brick that you build a building. Okay, building something by assembling smaller components in like building a car engine, so atom by atom assembly. In nanotechnology, self-assembly of atoms and molecules is in chemical and biological systems. Available MEMS product, microsensor, acoustic wave, biomedical, chemical, inertia, optical, pressure, radiation, thermal, microisolator, microvalve, micropump, microfluidic, electrical, optical relays and switches, gripper, linear and rotary motor. Read-write head in computer storage system, insect printer head, micro device components, example mini robots and toys and micro car, surgical and mobile telecom. This is a micro level dimensions. Enabling technologies for miniaturization, microsystem technology, the top-down approach and bottom-up approach. Nanotechnology is 0.1 to 0.1 micrometer, 0.1 nanometer to 0.1 micrometer. Microsystem technology 1 micrometer to 1 millimeter. The MEMS advantages, IC technologies used integrated multiple and more complex function on a chip to form a monolithic systems. Batch fabrication reduced manufacturing. Micro components make the system faster, more reliable, more portable, changer, low power consumption, easily and massively employed, easily maintained and replaced, easy to integrate into systems or modify, a little harm to environment and capable of incorporating exploration of the physics domains. MEMS as a microsensor. This is a block diagram of the micro pressures and microsensor. Input signal is given to the sensor, sensor signal is converted to electrical signal, then that signal is applied to the transduction unit. The transducer converts the signal into electrical. This is MEMS is a actuator. That important block, micro actuation element, transduction actuation element. This diagram is MEMS using electrostatic actuation. A microsystem, it is an engineering system that contains MEMS components that are designed to perform the specific engineering function. The components of the microsystem, transduction unit, sensor and actuator. All the combination of three we called it the microsystems. This is a micro gear, micromotor, this image for microdarphine. This is a micro optical components for switching. This is a micro lens. This is an important micro sensor and micro actuator. Under the micro sensor, acoustic wave sensor, biomedical and biosensor, chemical sensor, optical sensor, pressure sensor, stress and thermal sensor. Under the micro actuator, creeper, tweezer, motors, relays, valves and opticals. Application of the MEMS and microsystem in biomedical industry, disposable blood pressure transducer, infrastructure pressure transducer, angiology pressure sensor, infusion pump pressure sensor, diagnostic and analytical systems such as capillary electrophoresis systems, biochips, human care support system, respirator, lung capacity meters, parametric correction and instrumentation, medical process monitoring, kidney dialysis equipment, drug delivery system, devices for invasive surgery, artificial equipments. That BioMEMS, MEMS working as a BioMEMS, MEMS accelerometer found in the pacemaker and defibrillator, MEMS electrode and RF transmitter found in electromagnetic path monitor. This MEMS is our DNA, MEMS is in biomolecules, MEMS and nanosize cantilever used to identify the virus. Thank you.